Hello everyone, I'm Dr. Godandaraman. In this section, we are going to discuss with solenoidal, irrotational, scalar potential related problems. See the problem. Prove that f vector equal to 2x plus yz into I vector plus 4y plus zx into j vector minus 6z minus xy into k vector is solenoidal as well as irrotational. Also find scalar potential of f vector. Solenoidal is nothing but solenoidal. The divergence, what is a divergence? Divergence is nothing but del dot f vector is a divergence. If the divergent value 0, then it's a solenoidal. And then irrotational. Irrotational is nothing but the curl del cross f vector curl, the value 0 and then is a irrotational. This is a what? It's a divergence. Divergence value 0, solenoidal. Curl del cross f vector value 0, irrotational. And then scalar potential. Scalar potential is nothing but del pi equal to f vector. Del pi equal to f vector. So this is our to prove this 3 part. Now first to prove that f vector is solenoidal. To prove solenoidal. Now the divergent del dot f vector equal to, what is the del value? I vector dou by dou x, j vector dou by dou y, k vector dou by dou z. This is the del dot f vector. So what is the f vector? 2x plus yz. 2x plus yz into I vector plus 4y plus zx into j vector minus 6z minus xy into k vector. Now multiplication of each and every term. To multiply the first term into this first term. So when we multiply first term, in between dot product. So I dot I. So what is the value? I dot I, j dot j, k dot k value 1. I dot j, j dot k, k dot I value 0. Therefore, now the first term when we multiplied here, I dot I 1, therefore dou by dou x of 2x plus yz. Then plus first term, second term, I dot j 0, I dot k 0. The next term, j dot I 0, j dot j 1, dou by dou y of 4y plus zx plus k dot I 0, k dot j 0, k dot k 1. Therefore, this is a k dot k 1 minus dou by dou z of 6z minus xy. Now differentiate partially with respect to x, because of here x is the variable. Now here x variable, y means y variable, z means z variable. Other value to consider constant. When I differentiate two constant, x differentiation 1 plus y z, the total values are constant. The whole total value, see, this is a constant, this is a constant, 4 constant, zx constant, 6, this xy, every value constant, 0 plus 4 constant. When I differentiate y 1 plus zx 0 minus 6 z1, then minus 0. Therefore 2 plus 4 minus 6, 0. Divergent del dot f vector 0. Therefore f vector is solenoidal. Hence prove. Then to prove irrotational. To prove irrotational. So irrotational is nothing but curl del cross f vector equal to 0. So del is I vector, j vector, k vector. The del value dou by dou x, dou by dou y, dou by dou z. The first f vector I coefficient value 2x plus yz. Then j coefficient value 4y zx and k coefficient value minus 6z minus xy. This is a determinant. Now to calculate this determinant, leave first of all I to find the determinant I vector. When I am choosing I vector, to leave the row and column. When I am leaving row and column, now we have this is a cofactor form. Now this cofactor cross multiplies this term minus of this term. Therefore I vector into this leave column and row dou by dou y of minus 6z minus xy. When I multiply minus sign inside, it's a plus, minus dou by dou z of 4y plus zx. And then next minus, y minus means plus minus plus minus plus minus plus minus plus. So this is the form. So the first row plus, next value minus. Now minus j vector into, leave again the column row dou by dou x of minus 6z plus xy minus, and then minus dou by dou z of 2x plus yz plus k vector dou by dou x of 4y zx minus dou by dou y of 2x plus yz. Now therefore now the first variable y, when y means here is only y, other value is constant, z, this is a z variable, x variable, z variable, and x here, so x is a variable, y means y is a variable. Now differentiate partially with respect to first term y. Here y means first term constant 0 plus x y into 1 minus dou by dou z, the first term 0, then plus 1 into x. This is a I term minus j vector. So dou by dou x means first term 0 plus x differentiation 1 and then y constant, then minus dou by dou z, 2x constant 0 plus y constant z variable differentiation 1, and then k vector dou by dou x 4y 0 z x differentiation 1 minus dou by dou y 2x when I differentiate 0 plus y differentiation 1 z constant. Now the first term I vector x minus x minus j vector y minus y plus k vector z minus z. Therefore 0 del cross f vector. Therefore f vector is solenoidal. And then to prove scalar potential, find the value of scalar potential. Find the value means del pi is nothing but del pi. This is a scalar potential. So the scalar potential del pi equal to f vector. So del is I into dou by dou x, j into dou by dou y, k into dou by dou z into pi equal to f vector 2x plus yz I vector plus 4y plus zx j vector minus 6 z minus xy into k vector. Now multiply pi inside this bracket, I vector dou pi by dou x, j vector dou pi by dou y, k vector dou pi by dou z. Now the right hand side f vector value 2x plus y z I vector, 4y z x j vector minus 6z minus xy into k vector. Now comparing the coefficient of comparing the coefficient of I vector, j vector, k vector. So when I compare the coefficient, dou pi by dou x equal to, because here I, and then j coefficient, k coefficient. Dou pi by dou x is equal to 2x plus y z, and then dou pi by dou y equal to 4y plus zx, dou pi by dou z equal to minus 6z plus xy, minus I multiply inside this term. Now, so this is a term. Now integrating partially with respect to x, here integrating with respect to y and integrating with respect to z. Therefore, when I integrate this, pi equal to, now x only variable, other values are considered constant, 2 into x integration x square by 2 plus y zx, when y is at derivative dx with x, plus the constant is nothing but independent of x, the function f1 of y comma z. And then when I cancel this 2 and 2, the value pi equal to x square xy z plus f1 of y comma z. And then for this integrating with respect to y, pi equal to 4y, so 4y square by 2, when I integrate y is the y square by 2 plus zx, because y is the only derivative zx y, f2 of x comma z, Now cancel this two terms. Now pi equal to 2y square plus xyz plus f2 of x comma z, and then other term integration with respect to z, pi equal to, when I integrate, pi equal to minus 6z square by 2 plus xyz plus f3 of x comma y. Now when I cancel this two term, 3. Therefore pi equal to minus 3z square plus xyz plus f3 of x comma y. Now consider this is a 1, 2, 3. Now combining the value, combining 1, 2, 3. When I combine this 3, first term x square, second term xy z, and the other term 2y square plus 2y square plus, so don't add xyz. So repeated term combined, repeated combined means, so you just write it only one time for the repeated values. If xyz repeated second time, so don't add 2 into xyz, just write only one time xyz, then plus minus, next minus 3z square, again xyz repeated, ignore this, plus f1 of y comma z, f2 of x comma z, f3 of x comma y. So these are the independent of x, y, z. Therefore to consider arbitrary constant c. So this is our pi value, x square plus xyz and then plus 2y square minus 3z square. So this pi is nothing but scalar potential of, therefore pi is the scalar potential of f vector. Thank you.